or annual tuition payments of 25,000 are paid at a future date. The payments will be funded by investing 1,000 at the beginning of each month. The last deposit will be made 6 months before the first tuition payment. Interest is nominal, 6%, convertible monthly. Calculate the minimum number of monthly deposits required to fund the total tuition. So here the most convenient common point at which we can examine the values of the tuition and the deposits is the time of the first tuition payment, because the issue here is that we don't know how many payments there are in the deposit. We know there are 4 tuition payments, but we do not know how many deposits there are. Now, if we knew how many deposits there are, like it's been in a few problems earlier, then the most convenient and easy way is to just bring everything to times 0. But here, times 0, if we try to bring everything to times 0, there will be some complicated expressions involved. And whereas if we collect everything at the time of the 4, at the time of the first of these 4 tuition payments, then at least we will get a definite number for these 4 tuition payments, and that will not involve a variable, which will be the case. They will involve variables if we try to bring everything to times 0 in this problem. Therefore, the simplest thing to do here is to collect everything at the time of the first tuition payment. So let's start. And the tuition payments are annual, therefore we will need the annual effective rate. So right now we are given the 6-month nominal rate. Therefore, we first calculate the annual rate by the equation 1 plus I equals 1 plus I 12 by 12 power 12, and I 12 is the nominal monthly rate. So I said 6-month rate, but actually it's the nominal monthly rate that's given. So, so it'd be 12, I 12 by 12 power 12, and I 12 is 0.06, and so 1 plus I ends up being 1.0617. And therefore, the value of the 4 tuitions at the time of the first tuition payment would be the first one would just be 25,000, since that's exactly the time at which it comes. Second one comes 1 year later, so its value at the 1 year previous time would be 25,000 times mu, and then 25,000 mu squared, 25,000 mu cube, and mu is 1.0617 to the negative 1. And then we substitute that, then we get the value of the 4 tuitions to be 91,615.67 at the time of the first tuition payment. So now we will also need to find the value of the deposits at this time, the time of the first tuition payment. And to do that, it's first convenient to find the value of the deposits at the time of the last deposit, because that way we can treat it as an annuity immediate. Remember, after the last deposit, there are still 6 months before the first tuition kicks in, and these deposits are happening monthly. So there is no direct way of going from these deposits to their value at the time of the first tuition. We'll have to first use our annuity formulas to calculate it at a natural time, and then push it to the time of the first tuition. So because remember, there are 6 months between the last deposit and the time of the first tuition. So therefore, if we calculate the value of this deposit stream as at the time of the last payment, we'll have to push it forward 6 months. So let's first focus on calculating the value of these deposits at the time of the last deposit. And as we discussed in an earlier problem, if you are finding the accumulated value at the time of the last payment, then you should treat it as an annuity immediate, because in an annuity immediate, the accumulated value sits at the time of the last payment. So First, we need the monthly effective rate because the deposits are monthly. So I12 by 12 will be the monthly effective rate, J, 0.06 by 12, that's 0.005. And as we said, if we need the accumulated value of an annuity at the time of the last deposit, we need to treat it as an annuity immediate. So the accumulated value at the time of last deposit will be the formula for accumulated value of annuity immediate, x times 1 plus j to the n minus 1 over j. Substitute j, n is unknown, so this simplifies to, and also substitute the x equals 1,000 because each deposit is 1,000. So this whole thing simplifies to 200,000 times 1.005 power n minus 1, where we are supposing that n is the number of payments which are needed to pay off all the tuition. So now, as we mentioned, we need to push this accumulated value of the deposits to the time of the first tuition, because that's the time at which we have calculated the 4 tuitions. That way we can then equate the two. And so to push it to the time of the first tuition, we have to push it forward by 6 months because this last deposit occurred 6 months before the payment of the first tuition. So to push it forward by 6 months, we'll have to multiply it by 1 plus the 6-month rate power 6, 1 plus the monthly rate power 6, because we're pushing it 6 months and the monthly rate is 0.005. So we'll have to multiply the deposit value by accumulated deposit value by 1.05 power 6 in order to push it forward 6 months. And then this accumulated value we would like to be equal to the value of the total value of the 4 tuitions. So we equate the two. And this dividing by 200,000 and dividing by 1.005 power 6, we get 1.005 power n minus 1 on the left and 0.4446, and then you add 1 on both sides and then take natural log, and you get n equals 73.75. So what that means is that you need 73.75 payments in the deposits to be able to pay the 4 tuition payments, but the payments have to be an integer. So 73 payments of deposits are not going to be enough. The calculations are telling you that you have to pay 73 payments and something, and therefore the minimum payments that you have to do is 74. And now just keep in mind that we are not doing 74 because this 0.75 is bigger than 0.5. We're doing 74 because it's 73 point something. So even if this was 73.1, we will still need a minimum of 74 payments to make sure that we are able to pay all the 4 tuitions. So this is a case of rounding up to the next integer and not just the usual mathematical rounding. And 74 is choice D.